Okay, so this diagram will wrap up the seasons. This is just like the diagram that was in your packet. I'm going to go ahead and start by just drawing a straight line that goes across the sun here and connects these 2 points here on Earth. And if we notice, my fairly straight line here is pointing to 2 different places. In the diagram here on the left, this line is pointing right to this line up here in the northern hemisphere, and on the right it's pointing to this line here in the southern hemisphere. Well, this line here, this line that I drew, it represents the line of maximum insolation, or maximum incoming solar radiation. It's basically the most intense light from the sun that's striking the Earth. And if we take a look here, that maximum insolation is striking the Tropic of Cancer here in the northern hemisphere. And over here it's striking the Tropic of Capricorn. For the southern hemisphere. When does that happen? This happens on the first day of summer for us, right here in the northern hemisphere. We call that the summer solstice. And again, that's the first day of summer. The first day of winter in the southern hemisphere is called the winter solstice. First day of summer for us in the northern hemisphere happens in June. And it happens anywhere from June 21st to June 23rd. For the winter solstice, it happens in December. And somewhere December 21st to the 23rd. And again, the winter solstice will happen on December 21st or 23rd, when the sun's most direct insolation strikes the Tropic of Cancer. And then for the northern hemisphere, when the sun's most direct insolation strikes around the Tropic of Cancer, that happens, that's the summer solstice on June 21st to 23rd. How about on the days in between? On the days in between, the sun's most direct insolation strikes right on the equator, and we call those equinoxes. But now a question to ask is, does it go from this left position to the top, or does it go from the left position down to the bottom? We need to keep in mind that the Earth goes around the sun in a counterclockwise fashion. So it goes around like this. And what that means is that if this is winter, this would be spring. And this would be fall. Another word for spring would be the vernal equinox, or just the spring equinox. And here we have the fall equinox. And that fall equinox happens in September. And this happens in March. And again, the days are 21 to 23. Now, how can I know the months? Well, if we take a look here, we know there's 12 months in 1 year, and we know there are 4 seasons. And if I do 12 divided by 4, that's going to equal 3. And what that means is we get a new season every 3 months. So if we just keep in mind that summer happens in June, or if you remember the winter happening in December, you can reason your way through the rest. So here we have June, July, August, September, October, November, December, January, February, March. So there's really nothing to memorize here. As long as you know one of the months for one of the seasons, you can know them all. And again, on the equinoxes, the sun will be directly overhead on the equators on both the spring equinox and the fall equinox, and those are 6 months apart. During the summer, we have longer days. And during the winter, we have shorter days. During the summer, the sun's insolation striking the northern hemisphere is more direct. And again, that goes for the summer. And here we have less direct insolation. And it's kind of equally spread out between the equinoxes. Now, one thing to keep in mind is that as we go from summer, approaching fall, and then fall from winter, we have a gradual cooling. a gradual cooling of the days. And then as we approach from winter into summer, we have a gradual warming. And as we approach from summer into winter, the days are progressively getting shorter. Days are progressively getting shorter days. And over here, the days are getting longer. Now, why does all this happen? All this happens for one reason and one reason only, because of Earth's tilt. We have a lot of stuff going on this sheet right now. It really wraps up everything that the seasons are all about. And I'm going to go ahead and clear this, so if you need to, you can make sure you can pause and go back. But when we take a look here, if the Earth were not tilted, if it were straight up and down, we wouldn't get this effect of the sun's most direct insolation striking different parts of Earth differently throughout the year. What it would look like, it would be like this. It would look a little something like this. This would be the sun. Here's the Earth. Here's the Earth. And if we went around the Earth and we weren't tilted, the most direct insolation would always strike right towards the equator, no matter where we were around the sun. And we wouldn't have the seasonal changes that we see right now. The days would all be of equal length all throughout the year. The temperatures would be uniform equally all throughout the year. So it's Earth's tilt that's really important for us in understanding why we have the seasons. But it's not just the tilt, it's what the tilt does for us. It gives us longer days during our summer. It gives us shorter days during our winter. It gives us progressively longer days as we approach from winter into summer, and progressively shorter days as we go from our summer into our winter. It gives us more direct sunlight in our summer and less direct sunlight in our winter, and equal amount of sunlights going from the fall into the spring. These are all the reasons for the seasons. If you have any questions, please feel free to Edmodo me or to go ahead and just ask in class.